Good morning. This morning we're going to look at solving a systems of inequality. That's our objective for today. We're on page 15A in your packet, so turn to page 15A. We're going to start off by just graphing a linear inequality, and then the next video we're actually going to graph a system of linear inequality, but we're going to start by reviewing graphing a linear inequality. So our first step in doing this is going to be to solve for y. Just like we had the slope-intercept form in the previous section, we're going to have to put these in slope-intercept form as well, if I can find a pen. So our first step is going to be to solve for y. So basically what we want to do is we want to put it in y equals mx plus b. Okay? We want to get it in that form, and then we're going to graph it just like we did with when we solved a system of equation by graphing. We start with the y-intercept, and then we use the slope to graph the next point. So if it's less than or equal or greater than, if it's less than or greater than, we're going to use a dashed line. If it's less than or equal to or greater than or equal to, we're going to use a solid line. What makes the difference when we use the solid line, what we're saying is that what is on the line is included in the solution. That's why we use a solid line to show that what the points on the line are actually included in the solution. That's what that means. Then what we found is that if it's less than or greater than, we're going to shade below the line. If it's greater than or greater than or equal to, we're going to shade above. And again, these are in your notes. And I will show you how to do this on your calculator as well. I want you to do it by hand, and then maybe tomorrow we'll go over how to do it on the calculator. If you have two or more equations, which this becomes the system is when we have two or more equations, then the solution is wherever it is double shaded. Where it's double shaded. So as the picture we had when we started, I think we can look at this. This would be said, the green part would be the solution to the system because blue and yellow make green. So this would be the solution. Everywhere there's green would be the solution. Okay, so let's do an example. We're starting with just one equation. Okay, so once again, we're going to start by using slope-intercept form. This is already in slope-intercept form, so our first part is done. So recall that m in this case is equal to 1/2, and b is equal to 3. So our y-intercept is 3. We start at 3. 1, 2, 3. Our slope is 1/2, so we go up 1 and to the right 2. Remember, we always go to the right. And then we graph our lines. Now, my line may not be that straight, but you have straight edges, rulers you can use. Now, because it's less than, I've already made a mistake. Because it's less than, my line needs to be dashed because it's less than. So I'm going to come back and dash this line because it's less than. So I'm going to dash this line, put some dashes there, and it's dashed because it's less than. What's on the line is not included in the solution. And then, because it's less than, I'm going to shade below. Because it's less than, I shade below the line. So my solutions, a little darker, my solutions are here. There we go. So my solution is any point in the shaded region would be considered my solution. Okay. All right, let's look at the second one. Now in this one we have to solve for y. So what we want to remember is that we want y by itself, so we have to move the 4x, for 5x. So I subtract 5x from both sides. I get negative 4y is less than or equal to negative 5x plus 4. I can't add those together because they're not like terms. Now, when I divide, recall, when I divide by a negative number, this flips. it changes. So now this becomes y is greater than or equal to 5/4 x, that will now be positive because the negative divided by a negative is positive, and 4 divided by -4 is 1, -1. So it's 5/4 x minus 1. Okay? So that means when I come up here to my handy-dandy graph, I start at -1. My slope is positive 5/4, so I'm going to go up 5, 1, 2, 3, 4, 5, and over 4, 1, 2, 3, 4. And I'm once again going to draw my line. And this time my line should be solid because it's greater than or equal to. That equal to makes it a solid line. So recall down here we flipped it so it was greater than or equal to, so I have to now shade above that line. So everything above this line is now my solution. Everything above that line is my solution. Okay? I'm going to do this next one with you, if I can get this out of the way. Once again, I like it when they're already in slope-intercept form. I can see that my slope is -1 and my y-intercept is 2. So I start at 2. My slope is -1. So remember, if it's negative, I go down and to the right. I go down and to the right. I always go right. And I've finished that pattern. Now, because this is just less than, I am going to do a dash line. Okay, that's a dash line because it's just less than, it's not less than or equal to. And because it's less than, we're going to go below the line. So going below the line, I get this. So every point where it's shaded is part of the solution. Okay? Now, what I would suggest that you do is I suggest you pause this video and you do the next 3 and then come back and find the solution. Okay? So the solutions to this, I'm going to do this right quick. If I solve for y, I get x plus 4y is greater than 12. I subtract x. I get 4y is greater than -x plus 12. Divide by 4. I get y is greater than -1/4 x plus 3. So I'm going to start at 3. 1, 2, 3. I'm going to go up. Is it negative? It's negative. So I go down 1 and to the right 4. 1, 2, 3, 4. It's a dashed line because it's just greater than. It's not greater than or equal to. And I graph it. It's greater than, so I'm going to shade above the line. And it looks like this. Everything above that line is part of the solution. My second one is already in slope-intercept form, so I start at -3. 1, 2, 3. My slope is -2, so I got down 2 and to the right 1. Okay. This time my line is solid. For some reason I went down 2 and over 2. You know why I did that? Up 2 and over 1, sorry. Let's erase this and start over again. Got too many dots there. Okay, so sorry about that. You go down to -3, 1, 2, 3. My slope is -2 over 1, so I go down 2 to the right 1. I can finish that pattern by going up 2 and to the left 1. My line will be solid because it's greater than or equal to, and because it's greater than, I shade above the line. La 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 la. So everything above that line, despite, you know, it looks like I've been drinking, I haven't, is part of the solution. Okay? All right, last one is also in slope-intercept form. So I'm going to go down to -5, 1, 2, 3, 4, 5, and this one's going to make me break my rule because I can't go down 3 and to the right 4. I have to go up 3, 1, 2, 3, 1, 2, 3, and to the left 4, 1, 2, 3, 4. But I do that because there was not enough room to go down on this graph. Okay, once again, this is the solid line, and it's less than, so I'm going to shade below the line. And that's my graph. Okay, so that is it for graphing inequalities. What I would like for you to do is I would like for you to, this video is ending, I would like for you to do page 15C in your packet. 15C in your packet, and it is, I think it's 6 questions, no. Yes, it's 6 questions. So I want you to do the 6 questions on page 15C, and when you are done, I want you to come let me check it. Have an amazing day.